Welcome back, everyone. So we had predicted that we might have some delays, and that's why we left half an hour at the end as like a buffer period. So we're not going to eat into our next session. This session we have called as Teams Driving AI Adoption in Large Organizations. So of course, when we had created our cohorts plan, we said, oh, small, medium enterprises will apply. But we actually got some applications from really big organizations who don't particularly need the support that we offer, but they came with this idea that, oh, we want to give back to the community and we want to be part of this. And the teams who joined us, they were from a smaller team, and it was a really good insight into how big companies work. And I think one of the panelists said that sometimes in big companies as well, the teams work isolated and they perform like their own small medium enterprise within the industry. So I'm very happy to welcome three speakers. Mia is online, and I think Lele, when she comes back, will ask Mia to be projected on the screen, who will be representing NHS England data science team that Mia and Harriet Sands have represented as experts in residence. FTI team was really, really big, and I hope Haneen Abdul Kader is online. Yes, Haneen, I see she's online. They are also based in London, but they are also going through a lot of work. So they are lots of deadline in March. So I'm really grateful that Haneen could join and represent her team. And finally, we have Joe in the room. So Joe, you would be the only person in the room. So I think the order, I'm going to make sure that the order is not ruined, but Mia and Haneen, you can share your own screen. So how about we just actually take the online folks, and as I said, Lele, there you go. Lele, how will we do anything without you? So we have two speakers online. Can you project them? And can we start with you, Mia? Just for a reminder, Mia, Haneen, and Joe will talk about 5 minutes about their case studies. Their case studies are amazing, very, very close to being published on Zenodo and most likely in next couple of days. So you would have a chance to read that thoroughly.
In machine learning, not so much AI. I suppose AI is recent to everyone, but in my particular case, this has been a great networking and upskilling opportunity for my first year in my role as an AI data scientist at CFAS. The question I wanted to kind of get out of the experience was, in an organization that is as diverse in terms of scientific disciplines, because we have, sedimentologists, we have specialists in oceanography, marine biology, various different marine disciplines. For all those different disciplines working in different sectors for different customers around the world, how do you standardize the working practices in the organization? And I think I got the impression that this is a well-trodden path for the Turing Way. So CFAS, that stands for Centre for Environment, Fisheries and Aquaculture Science. Fisheries, I would say, is the bread and butter of what we do. We have fisheries time surveys going back. We just ticked over the century time series mark for fish for cod in the North Sea, that is specifically. But whilst we're out there on a research vessel collecting data for fisheries, we're also looking at other things like eutrophication, pollution levels, and generally collecting opportunistic data whilst we're out there. We're a Quango, so CASO autonomous non-governmental department organization. We essentially scientifically advise in an impartial way, advise DEFRA and therefore government how many fish to catch. The fundamental question there being, how many fish are there out there? I can't underemphasize the importance of international collaboration in fisheries. Fish do not care about borders. It wouldn't be possible for us to monitor the entire ocean. So naturally, what we do is we put our data together into international forums, then we all get to stay together and look at the data together as an international community to determine how many fish we can catch for the different species. It's very data centric what we do. And the data we're talking about, it's still nets in the water. You know, we're still going out there fishing, catching the fish. But we're at an inflection point in that by 2030, 30% of the UK's seas are scheduled to be MPA, marine protected areas. There's a huge explosion in offshore wind farms. We can't fish amongst those. There's a real need for us to transition away now from using the old-fashioned technologies of nets, things which have very reliable time series tied to them, and kind of move over to using different sensors, to using AI. And what do? I guess I've explained now. I'm a data analyst. One of the things I've been working on in the background throughout this year, and what you're looking at on the screen here, that is a chain diatom from the Thames. It came off an instrument called the flow cytometer, which is on our research vessel. It's an instrument which I believe is medical in origin, but it's been mapped over to be used on seawater, and it takes a photograph, and whilst it's also photographing each particle in the water, this is through our saline intake on our ship. It's also shining a laser at each of those particles. The backscatter go through diffraction gratings. You get tons of data for everything that's in the water. It's a great candidate for machine learning and AI in plankton science. But I guess to wrap this up, the pennies kind of dropped towards the end of the year that we need to change our calibration practices for this specific data example for it to be AI ready, in that the fluorescence and the backscatter spaces that are occupied by the cells in the water, we need to be using similar things to calibrate them. So we need to change our research practice internationally to do that. All right. Moving on finally. So what was I looking out to get out of the program? Like I mentioned before, we all, in our organization, it seems in the cohort, we all talk about, we want more of this. We want more standardization, better integration, more reusability, transparency, fairness, interoperability, etc. That nobody says we don't, nobody's against that, but how do we actually do it? And how do we do it in an aligned way when there are so many options to us as scientists, when we also work in such different fields, it seems. So I mean, that's a question I brought up to people quite a few times in the cohort, and obviously there is no silver bullet. It seems that you need constant management, retraining, and there's no easy way out here. I'm a subscriber to your principle that it has to be community led and ideally bottom up, you know, us grunts getting together and working in embracing tools which allow us to align better. And also I'm looking here for a carrot ultimately rather than a stick. So as I mentioned, I did have sorry, that's kind of cut half the slide off there, but I had an explore on the Turing Way. Clearly, this is something that has been walked several times through. I'm not innovative in this way of thinking, but I was looking for a tool ultimately that would help people align better. And it had to be a tool that I myself would want to use and work with day to day. Because if I don't see the value in it, I don't think my other colleagues, when I come back and present to them, are going to see the value in it either. So my initial thoughts turns to our organizational GitHub. I'd say the single best thing, the single healthiest change that I've seen at work has been the embrace of GitHub for collaboration and for version control. There's a strong kind of carrot here in that it can quite literally save you that version control when you've messed up your research. And I think people are really seeing the value in that. So I was really trying to find something that would kind of take that to the next level. My first thoughts were, okay, for my performance management review, maybe I can generate some Python tooling that will interact with my GitHub and then make me look good. Actually, I think it's a complete self-own. What I've found is that the vast majority of my work is not in the public sector. I am pretty invisible out there, which I suppose is good thing that I've learned, and I can quite easily course correct for that. I know in our organization, it's bureaucratically more difficult to make a repository public after the work rather than doing it from the start. So that's quite an easy behavior I can correct for. But I didn't think it was the tool I was quite looking for. In the end, the conclusion I came to was that the continuous integration feature of GitHub Actions was basically what I was looking for. And that's what I intend to train people on when I get back over in April, when I get back to work. So my reflections on the experience, we at CFAS, I mean, we love ethics and we have an ethics panel, but when we're talking about ethics, we're not using the language in the same way that you're often talking about ethics. We're talking about whether it is ethical and necessary to catch a fish, how we should handle the fish, whether it needs to be euthanized and how to do that as humanely as possible. Ethics in the data sense and the bias and potential inequalities of new technologies being implemented, it's a whole new world to me, frankly, and that is my biggest learning from this. It's introduced me to these new tools that I was completely unaware of. And the last thing, you often talk about different groups in society being penalized by AI tools. And there are so many analogies that just translate directly to, instead of groups of individual people, to groups of fish or individual species. Bad AI can really hinder a specific group in society, but it can also potentially drive a species extinct if we don't do this right. If we don't transition safely to a different network of sensors for monitoring fisheries. Yeah, so as I said, I intend to present back when in April, and I'd like our tool to end up somewhere at the top of this ladder of participation, stolen straight off the Turing Way. Yeah, thanks. Yeah.